on the recording, okay? So let's recap on what mathematical principles we have covered. The first one was any number times one stay the same. And we know that's a statement. And that is a true statement, right? That is a true statement. Number two, okay, number two. Have we covered number two yet?
I don't think we have.
What was it? Did we cover number two yet? I don't think so. Okay. The second principle is any number as 0 stay the same, which is the second one on your on the notes. Does that sound like a real you know, a principle we would agree? We're laying the foundation for the entire semester. Okay, we're laying the foundation for the entire semester. So the second principle is any number as 0 stays the same. Did I get my grammar correct? So A represent any number and plus 0 stay the same. Does everybody agree with that principle?
Yes.
Do we remember that principle ever being used? Have we used it before?
Yes.
When did you remember it's being used? Oh, what was the situation that it was being used?
I have some ideas.
Okay, go ahead.
Completing the square method.
That's right. Okay, that's one of the situations that completing a square will be used. And we will see this technique being used and reviewed again in this course. Okay, for example, I'm going to give you an example. Okay, for example, okay, we wish to complete a square for an expression. For an expression. Okay, we wish to complete a square. Okay, and we understand this is a statement. This is description of a rule, isn't it? This is a description of a rule. And we don't want to change the rule. Okay, what do we mean we don't want to change the rule? Because as a description of a rule, which is a function in this case, it is a function, our x will be serving as the input for each value x is being assigned to a numerical value. And we're going to apply this rule and it produces an output. Okay, so we don't wish this to be changed. This rule will not change. But we want to see a perfect square in this expression. Why do we want to do that? Did I do this before?
You said something about the vortex. We can find the vortex.
That's right. We've done this example, didn't we?
I don't remember exactly. Maybe the
Okay.
class can help us.
Could you guys refresh me? For some reason, I thought we might have done this. Or maybe not. Okay. Okay, I just do it quickly. So okay, very good. Thank you for your responses, okay? So without changing the rule, we can only add a 0. But we're gonna add a 0 wisely quote and unquote, right, to fulfill the goal of completing a square. So what we do here is that we want to maintain the equal sign. You see, equal sign is not just a simple symbol. It is a phrase. It is part of a sentence of a statement. Okay, so we're basically saying this rule is going to be the same as this rule plus 0. Right, so we're applying the principle number 2. And now we're going to choose the 0 as 1 minus 1. Plus 1, subtract 1. So this to ensure, the first plus 1 is to make a perfect square. The subtract 1 is to make sure these two are still the same rule. You follow me? Now, as a result, if we group these 3 terms together and we factor these, and we are getting x minus 1 squared and then minus 1. Okay, so in terms of applying the rule, okay, this rule hasn't changed. This description of the rule has not changed. So whether we use this guy as the rule, right? So in this case situation, if I use this guy as a rule to replace, the previous rule, or if I use a different guy, if I use the last one, if I use this guy as the rule, the same input will produce the same output. Does that make sense, you guys? So by adding 0, it stays the same. So that's what that equal sign tells us. So this rule is the same as this rule, because for the same input, it produces the same output. And this rule is the same as the previous 2 rules. That means for the same input, it will produce the same output. So this principle number 2 is also very useful. Okay, in this semester, we're going to spend time in the section of quadratic. You can get started reading about it, and there are past videos you can watch how this has been done. It's a very important technique, and in your calculus class, and you will get to use it. You will get to use it. Okay, so that's 2 principles. These 2 principles could apply to any situation. They could apply to any situation. Okay, and these are fundamental principles. So let's look at principle number 3. What is principle number 3? I want everybody to write it down. Did you guys make those flashcards? I sent you the samples of making flashcard. This is going to be your flashcard number 3. What is your flashcard number 3?
If A equals B, then A plus C equals B plus C.
That's right. If A is the same as B, so if 2 numbers are the same and we add the same number to them, the result will still be the same. Thank you. Then, when is this principle being used? This principle is used when we have an if statement. In what situation we have if statement? Equations, right? We talked about that yesterday, right? We have 2 kinds of statement in mathematics, 2 kinds of statements only. One is a statement and the other one is if statement. So this is the situation. This principle can only be used. This principle can only be used when we are dealing with an if statement. Because if A is the same as B, then A plus C is the same as B plus C. And of course, I'm going to quickly cover this because, for example, if you have 2x minus 5 equals to 3, you know how to, you know what to do with this, right? You guys know what to do?
Yeah.
Of course, right? But remember, this is an if statement. This is called an equation. Okay, equation is an if statement in mathematics. What it says is that if, okay, what it says, if, okay, this rule, okay, I'm going to give you a new description. You may not have seen this before. It says, if this rule, okay, taken an input produces the output of 3. What is the input? Okay, what is the input? That's the meaning. That's one of the meanings. Okay, the other meanings you can make, you can make it say, oh, 2 times an unknown number subtract 5 is 3. If 2 times an unknown number minus 5 is 3, what is the unknown number? Okay, so all of these are the interpretations, but they are all under the umbrella of if. It's an if statement. So in this situation, what would you do? You add 5 on both sides, and then you divide both sides by 2, right? So I'm not going to repeat that. You know what to do. You know what to do. I'm sure you know what to do. Any questions so far? But I want to give you guys all these interpretations. All these interpretations I'm laying out here is to preparing you for what's going to happen next. All right. Principle number 4. Principle number 4. Okay. What is principle number 4? If A is the same as B, then A times C is the same as B times C. Have I completed stating that principle?
No.
What did I miss?
You miss where it says where C does not equal 0.
Excellent. Thank you. Why this specification is so important? Is it dispensable? Right? When we were solving this equation, when we were solving that equation, right? We add 5 on both sides, and then we're going to divide both sides by 2. So we will be using principle number 4, right? So when we were solving this equation, and we will have 2x equals to 8. Oops. 2x equals to 8, right? And then we're going to divide both sides by 4 or multiply both sides by half. So we are actually applying that principle. Now, my question is this condition dispensable? If it is dispensable, why don't we just drop it? Are you guys with me? We know this principle for a very long time. Let me see the trend, see the chat. Is there a chance that you could divide by 0? Can we divide by 0? We certainly cannot divide by 0, right? But can we multiply by 0? Because this says multiplying. The answer to the question in chat by Wilbur is that, is this chance that you could divide by 0? No, we should not. We should never ever divide by 0. Never. But can we multiply by 0?
Yes.
When we multiply 0 with any number, we still get 0. So why couldn't we just remove this accessory? Right? So if we remove this accessory, what has this principle become? Wouldn't that be shorter and cleaner? Why in every textbook, from beginning algebra, from pre-algebra, all the way through calculus classes, calculus textbook, they all have that in writing. Have we thought about that? Is it really necessary? Okay, I'm going to give you the answer. The answer is, it is absolutely not dispensable. It's indispensable. Okay, it's absolutely indispensable. Because if this condition is removed, the entire mathematical field as we know it will collapse. I'm not even exaggerating. I'm not exaggerating. Okay, I'm going to show you why. Are you ready? Are you ready?
Yes.
All right. Okay, so if the principle is such, okay, so we're going to start a new page. If this is the principle, and we're going to use it, right? There's no restriction. There's no restriction on what C has to be, right? Therefore, we're going to still start from the same place. If A is the same as B, right? Then I want you guys to write it down with me. Okay, so we're going to apply this principle. Okay, we're going to apply this principle. If A is the same as B, then, oops, sorry. Then A squared is the same as B squared, right? Right? And A times B is B squared, right? Can I do that? If this is true, under this umbrella, we square both sides and we multiply both sides by B, we're good, are we? So if this is true, then this is true, and this is true. And what is more, A squared minus B squared will be 0, right? And A times B minus B squared will be 0, right? Does everybody follow me?
Yes,
Because you see, I multiply both sides, by the same number. So if a squared minus b squared is 0, and ab minus b squared also is 0, so they're both 0. Therefore, could I claim that a squared minus b squared is the same as ab minus b squared? And they're the same, right? Because they're both zeros, right? This is 0. And this is 0. And 0 equals 0, right?
yes.
Okay. And next, I'm going to factor both sides. Yesterday, we talked about difference of squares, right? Conjugates. So now a squared minus b squared, we have a plus b multiply a minus b, and we know that's true. And on the other one, we're going to factor. So we're going to have a minus b times b. They're all factored, right? And then we're going to cross out a minus b on both sides. And we get a plus b equals to b, right? You see, these two are crossed, right? And a the same as b, right? So a the same as b. So a plus b is b plus b equals to b. Then as a result, we get 2b equals to b. And we divide both sides by b again, and we get 2 equals to 1. If 2 equals 1, we keep going, then 3 is 2, 2 is 3. 3 is 4. 4 is 5. 5 is 6. Can you guys imagine what happens? So 1 is 2, 2 is 3. 3 is 4, 4 is 5. So all the numbers we know of, they're all the same. See if the mathematics, theory doesn't collapse or what? So what went wrong here? Which step do you think will need that requirement of C cannot be 0?
Professor, just the line 2 parentheses, a plus b, a minus b equals a minus b times b. When you eliminated a minus b, in fact, you divided both sides of equation by a minus b. So that's why they were out.
We were dividing by 0, right?
Yes.
Did you guys see that? We just talked about we cannot divide by 0. And we cannot multiply by 0 either, right? Because if you reverse the step, you're dividing by 0. Right? So this is the step will cause the 2b equals to b, 2 equals to 1. Okay, so we must have that requirement. Do you guys follow me? So this principle is absolutely indispensable. So principle number 4, whenever you use principle number 4, you have to make sure the number you multiply or divide cannot be 0. You actually have used this before, okay? But I'm not gonna go in there to review that part because in the later, we're gonna have specific sections and areas we're gonna cover these. All right, so this example shows that it's absolutely dispensable indispensable, sorry, to have C cannot be 0. So on your flashcard, you must have where C is not 0. I'm glad you guys paid attention to that and put that in your flashcard. Now, principle number 5. Okay, principle number 5. What is principle number 5?
A times B equals 0, then like, I don't know, you call that little sign, then A equals 0 or B equals 0.
Okay,
It's a
very good.
product of two numbers is 0 if and only if one of them is 0. Correct? I think that's where we're
Wonderful,
at.
wonderful. This is what I copy and paste from the notes, okay? And here I introduce a new term called if and only if, which you are gonna use in some situations in mathematics, in your calculus classes, okay? I'm gonna explain to you. This one sentence actually imply two sentences. Okay, this one sentence, okay, if and only, just because we have if and only if, and you can see this is the arrow, this is like a two-way street. You can move to the left, from left to right or right to left. Okay, so this principle involves two sentences. Okay, two sentences implied. The first sentence, okay, you can see in the entire process from the beginning to now, we mainly try to use words, right? We mainly are using the words. Let me see the chat. Okay. First sentence. What does the first sentence says? It says if a product with two numbers is 0, then one of them is 0. That's the first sentence. Okay. The second sentence, okay, so you guys get a head start on calculus. Okay. The second sentence says if one of the two numbers is 0. Okay, so this is if. If one of two numbers is 0, then their product is 0. Okay, that's what if and only if. This if and only if meaning that if this side is a condition, that will be the conclusion. You follow me? Vice versa. If the other side becomes a condition, and this first side will become the conclusion. You guys know that condition is a condition, conclusion is a conclusion, right? If we have a condition that you know the product of two numbers 0, then one of them must be 0. So this is the part that you guys use a lot, and it's called a zero product property. Okay, this is called zero product property in algebra classes. The second sentence, it's often not used, and you already learned that in a pre-algebra class. Do you follow me? So that's why the second sentence oftentimes was not really used, because we take it for granted. We know that in any product, if one of the number is 0, the product is going to be 0. No question asked, right? But when we put these together, this will make a two-way street. This makes two-way street. You can go from left to right, right to left. And this kind of situation is rare. For example, in principle number 3, in principle number 4, we didn't state them that way. Right, we didn't say them that way. So this even only if implied a two-way street, which you have arrows in both directions, imply that if this is the condition and these will be the conclusion, and vice versa, if this is the condition, that will be the conclusion. All right, now we have used this a lot. Okay, for example, we have an A times B equals 0 case, right? You might be having, say, x minus 2 and multiply x plus 5. Do you know what to do next? This is an if statement. This is an if statement, right? If the product of two numbers is 0, then one of them is 0. So our next step is doing what? You guys know the next step, don't you? X minus 2 is 0, or x plus 5 is 0, right? We have learned this. You guys know, you guys know this, right? We use zero product property. Okay, and the rest I'm not going to complete it, just for an example, to show you this principle is used a lot. Guess what? In your calculus class, you will continue to use this principle. You will continue to use principle. I can even tell you which chapter, chapter 4. Okay, when you need to do the optimization. Okay, in that chapter. But anyway, I'm not going to go further into that. So this is principle number 5. Now, principle number 6. Number 6. What does principle number 6 say? It's pretty long, isn't it? Since you guys already put them on the flashcard, you have read it. Could someone explain to me what is principle number 6?
Product / quotient of two numbers is positive if and only if the two numbers are on the same sign. Like if plus and plus equals plus, but minus times minus is still positive, like that, yeah.
Wonderful. And what if the product of two numbers is negative? Then the two numbers are of opposite sign, right? So this is something you have learned long time ago. You probably even take it for granted, right? A positive number multiply a negative number is going to be a negative number. A negative number times a negative number is going to be a positive number. Who doesn't know these? Everybody, right? Everybody, every one of you knows this, yes? Could you guys tell me you know this? Because if you don't know this, then you should not be in this class. And you certainly don't need me to tell you these principles. And in this semester, I'm going to show you how these principles are being used in a lot of the familiar materials you might be familiar with, maybe a little bit rusty, and you will see these principles continue to be used in calculus. So all 6 principles are covered. All 6 principles are covered. Okay, you got your flashcards. Okay, And when you multiply two positive number, you get positive number, right? When you divide two positive numbers, you get a positive number. So these are what it means. If you multiply two negative numbers, you get positive. You divide two negative numbers, you get positive. Now, if you look at these forms, I wish you to recall all those years you were in elementary algebra and intermediate algebra. How much time have you spent on factoring?
Personally, I feel like I spent way too much time on factoring.
Way too much time. But you remember you spent a lot of time factoring.
Oh yeah, oh yeah.
Did you enjoy it?
Only
Sometimes,
towards
right?
the end. I kind of, it wasn't terrible. I kind of liked it.
But have you ever asked why?
Like, why do we factor?
Yeah.
Isn't it to find an x value if there could be multiple x values? Like when you have oh gosh, sorry, I'm like spacing right now.
When you have more than one solution.
Yeah, more than one solution. Yeah, pretty much.
More than one solution. That's why you factor?
There's like well, we would also factor to find the GCF, or kind of depends on like what it's asking.
Very good. I'm glad you still remember some of those factoring techniques. Let me tell you the reason why. The reason why you factor all those factoring expressions is because of principle number 5 and principle number 6. Okay. Because principle number 5 and principle number 6, that's why we do all those factorings and we practice a lot, because those are called basic skills. And you will continue to need factoring techniques, and you will continue to need principle number 5 and principle number 6. In this semester as a review class, and I will show you how these principles have guided our steps. With that understanding, I hope that you will find math actually is not that complicated. Okay, so without further ado, we're done the principles. Right? Yay, did you write them down on the flashcard?
Yes.
Please do, okay, please do. And I sent you a PowerPoint, a PDF file for the flashcards. Those of so of course some of those cards we haven't discussed, and we have covered the definition of function. So please write that down as well. And the next thing, which is essential for us to continue, we're going to work on the truth table. Okay, we're going to work on truth table. To me, to conduct the class today, this semester, it's essential for us to know truth table. Truth table is the foundation of logic. Okay, truth table is the foundation of logic. And mathematics is all about logic. It's actually not really entirely about numbers. Of course, numbers are involved, but it is actually about logic. Okay, so in this semester, I'm going to build in a lot of logic in the math we do. Okay, to do that, we need to deal with the word and the word or. Okay, so let's see what is the truth table. Do you guys have it on your second page? Okay, and 2 words. Or. Okay, And or. What's the meaning of and or? Can anybody tell me? And or, these are two words. Not only are used in mathematics, they're also used in legal ledger. Okay, for example, if your car is registered under, let me take my own example. Suppose that one of our cars is registered under my name and my husband's name. Depending on the word and or, if any one of you in the future, you are in a family trust, you will find the word and or are essential. Okay, so the meaning of and or in mathematics is the same as in our legal system. You guys follow me? I want to get your attention, okay? I want to get your attention. That's why I mentioned this. It is so true. For example, in the car situation, it's a legal situation, right? And you know, one of our cars is registered under my name and my husband's name. In between, there must be a word. Okay, this word could be and this word could be or. Does it make a difference? Does it make a difference?
Yes.
How about everybody else? Does it make a difference? Walk said
Yes.
yes. It makes a big
Yeah.
difference, right? When you will start to feel the difference? What does and means?
Both.
Yes, go ahead.
Both.
Both, right? For example, if I want to sell the car and my husband say, no, I don't want to sell the car, can the car be sold if the car is registered under my name and his name?
No.
We cannot, right? But if the car is registered under my name or his name, could I sell the car even though he doesn't want to sell it?
Yes.
I can do it, right? He will be upset, but legally I can do it, right? Do you guys see the difference? And this difference is the same as in legal system, but he could also agree with it, right? You know, or still include the and situation, but if he doesn't, whether he agrees to it or not to agree to it, I can still sell the car. That's the point. Yes. So this is one of the major difference. So now in mathematics, we would be dealing with statement. We'll be dealing with statement. We talk about we have two kinds of statements, right? So we may have a statement 1. We may have a statement A, right? And we may have a statement B, right? So we have statement A and we have statement B. But we can also make a composite statement. We can say A and B. And we can also say A or B. Do you guys see that? Do you see that parallel connection? So when if we have two statements, of course, this one statement may be true or false. And this other statement can be true or false, B can be true or false. So in the making of A and B or A or B, and there could be true false situation. You follow me? Okay. Now, so let's look at a couple of situations. Let's look at a couple of situations. Okay, I'm making a table here. I'm making a table here. Okay, so we have a statement A. And we have a statement B. Statement A, statement B. Okay, and then we will have a statement A and B. A and B. If statement A is true, and statement B is true, statement A and B would be true, isn't it? Do you agree? I want to sell the car, and my husband says, sure, let's sell it. So A and B, right? So in the case of statement, if this statement is true, I'm true, he's true. So true and true is what? True. You agree, the car is sold. Yes? You guys follow me?
Yes.
Now, if statement A is true, but statement B is false, and we put these two together, one statement is true, the other statement is false. One person says, I want to sell the car, and he says, no. Can the car be sold? So when one statement is true, the other statement is false, A and B would be what? False. You follow me? In another situation, if statement A is false and statement B is true, right? This time I don't want to sell it and he wants to sell it. It's not going to make it either, right? So in this case, it is false as well. Last case. False and false. False and false is what? False. So when we compose two statements, when we have a composite statement, this is very important, you guys. Okay, this is essential. This is essential to your computer programming. In the future, you guys writing code, right? You need to understand this. Okay, this is what discrete math start with, but this is also essential for mathematics. Okay, so you can see A and B. A and B is only true when both are true. Okay, do you follow me? Now, let's look at another situation. Okay, let's look at the OR case. So this is the AND case. Let's look at the OR case. In the OR case, we're also going to have these scenarios. Our last column is or. Okay, so it's A or B. What will happen here? True or true is going to be true. True or false is what?
True.
Everybody? True or true? True or false, right? True or false? Okay, let me make this just a little bit smaller. Okay. See, my husband, the car is registered under my name or his name. I want to sell it and he doesn't want to sell. Could I still sell? So true or false is true. Do you follow me? False or true is true. And false or false is false. Truth table. Any questions?
Yeah, I have a question.
Hmm?
I'm sorry, can you just explain again, the true false is true situation again?
True or false is true. Do you mean this one?
Yes,
Okay. True or false, right? Say, for example, I want to sell the car, but he doesn't want to sell the car. But the car is registered under my name or his name. So I can make that decision alone. If selling the car is true, then I can still sell it. Does that make sense?
yeah, okay, thank you.
And vice versa. Okay, you guys really have to think about it because you guys have quizzes on these. Okay, you have quizzes on these. Foundation, we're building foundations. We're building foundations. Okay, so true or false is true. True and false is false. You guys with me? You really have to think about it. You really have to think the word and or and its their roles in this whole situation. Okay, so these are the two truth tables I want you guys to study, and there will be a quiz coming your way. There will be a quiz coming your way. So, okay, so this week you might have 3 quizzes. Okay, right now you got 1. Anyway, the notation wise, anybody has any questions? Notation, the word and, okay, this word, we have a notation for it. We use the symbol, the U turned upside down. Okay, and or, we use the word, we use the union, or the union. Okay, so you're gonna see these symbols. So it doesn't matter to me whether you use the symbol or you use the word. It doesn't matter to me. You can use either, either way of your choice. But you want to make sure you understand the meaning, which is essential. Okay, which is essential. This is the truth table. So we have laid the foundation. So could you guys put these truth tables on your flashcards? One truth table per flashcard. Don't squeeze them together.
And I can help them if they have any question in this regard, Professor.
Do you guys have any questions? All right, so we're gonna proceed. I'm not gonna go over everything in the same order of the pages, but I want you guys to take a look at this quiz number 1 on page number 3 of the notes. And I want to tell you where this quiz came from. Okay, this is page number 3. Okay, so I'm going to share the screen with you. I'm going to bring that over. Right, this is on your notes on page number 3. Page number 3. I found these exercise in your calculus textbook at the beginning. Okay, this is like the quiz for students who are just about to take a calculus class. It's a kind of self-check. It's a kind of self-check. Okay, so I'm going to give you 5 minutes. I'm going to give you 5 minutes. Okay, we're entering this pre-calculus class at this point. At the end of the semester, you should be able to do all of these questions correctly.
In 5 minutes?
How about 10 minutes?
Yes,
10 minutes?
that's good. That's better.
Okay. No, we're not going to do all of them today. We're not going to do all of them today. I want you to browse them, but I want you guys to work on the first 7 questions. Okay, I want you to work on the first 7 questions in 5 minutes. Okay, so don't be scared. I want you guys to look at the first 7 questions. I'm going to give you 5 minutes. Okay, I'm going to step out for just a few minutes, and Farouz is here. Every one of you take your paper, pencil to self-check. Are you ready for calculus class? At the end of the semester, we're going to do this again. Okay, so I'm going to step out for just a few minutes, and I will be right back. I just get some tea. And Farouz is here, and he could help you, but don't rely on him. This is a moment of self-check. This is a moment of self-check. Okay, so read the question. Determine whether each statement is true or false. We're talking about a statement. Each one is a statement. They're not an equation. They're not if statement. Okay. So of course, there's some if statement later, right? Can you answer all of these questions? Remember, I told you, we're going to enter calculus with one word, function. All of these have something to do with function. So now I'm going to step out, right? It's 9 right now. I'll be back at 9:05. And Farouz, you're gonna be helping them, but try to let them do it themselves, do it yourselves. Okay, do it themselves.
Sure.
This is not a test. I'm not going to grade you today, but I want you to self-check right now. Okay, 5 minutes. I'll be right back.
Thank you. Thank you. Okay, class. As you see, I have my board ready here. So anybody or everybody you want to unmute, go ahead and, volunteer. 7 questions only. And then as it says, determine whether each statement is true or false. That's the first step. Then if it is true or false, explain why. If it is true and if it is false, give a counter example. So Nicholas, I see you activated your screen, then you are still muted. Anybody else, please? We have only 5 minutes. Who wanted to answer which question? My board is also your help. You tell me, I write, everybody benefit from it. Interact, help each other. As Professor said, it's not a quiz or exam, so we can talk and share our thoughts. Okay, help each other. I would go number 2, whichever is easier. Okay, if you are not sure about any of those, leave it for last, and you may get some idea with the rest of the class helping each other. So Nicholas, or yes,
What's up? You
tell
know,
me which one do you choose to answer?
which
True
one
or
do I
false?
choose? Like
Yes.
to prove? Let's do 3.
Number 3. Okay, number 3. Nicholas, I just write N for here. Number 3, and you say, is it true or
It's
false?
true. It's true.
Let me write it also. Number 3 is a square root of A times B equals a square root A times the square root B. And your answer is true. True.
Yeah.
Okay. And so if it says if it is true, explain why.
Gosh, I don't remember. It's been like
No,
3 months. Since
No. Just say, yeah, for you make a number, you make your own example from this general equation. You say for A equals a number and B equals another number, we are going to prove it.
Oh,
So A, what? Choose a 1-digit number or 2-digit.
7. 7.
7.
Yeah.
B,
8.
8. Therefore, a square root of 7 times 8, right? Is it equal? We are going to put the question mark. So basically, 7 times 8 is what, Nicholas?
56, right?
So I
Yeah.
was checking your timetable. Good job. And then here is it equal? The square root of A is 7, and then times a square root of 8. So is it equal? Can we do anything to the right-hand side when we have a square root? Product of the square root. What do we do? What do we check first?
1 second. The right-hand side, meaning the root 7 times root 8. We can
Can
factor out
we?
the root.
Can we do that or not? If we can, why we can? Because I want to hear the keyword.
Wait, I'm confused what you're asking. I'm sorry.
So yes, can we multiply these two square roots? Yes, we can. Why?
Yeah.
Because their index are same. They have the same index, which is invisible too. So if we have a same index, therefore we can multiply them together. Therefore, here comes 7 times 8, 56, and check mark, happy face, true. Is you got it. So you said number 3 is true, and you proved it. Why? You explain it. You choose 2 numbers and work it out and show it is true. So this is one way, okay? This is so far based on pre-calculus. It might be true or false, and this is the class we are gonna complete our knowledge through this pre-calculus with the help of Professor Wang. Going through all those fundamentals, flashcards, 6 self-evidence, rules, and then truth tables, and on and on and on through the whole semester. So these questions are very powerful questions to tell us where are we now, and then by the end of semester, how good we can answer all these, how good we have learned everything, which is going to lead us to learn about the concept of functions. Remember, she mentioned the big term about this class or calculus is function. We want to know, when we hear the function, we want to recall many things from our memory. How many types of function we have, so on and so forth. So this is one of them. I see Professor is here. Maybe our time is up, Professor. Yes,
Yes, our time is up. Thank you so much, Farouz. I think
you're welcome.
I would like to meet you in office hours. I don't see your board. I don't see the writing you have on your board. I don't know how about the rest of the class. Do they see that writing?
Yes.
You do? Okay, you guys have good eyes. I just want to,
I-
maybe we can explore some other options and.
No, no,
for you to-
my marker is not as strong. I'm gonna get the new one while next time. So I'm sure marker is the issue here. Professor.
Oh, don't worry about it. We'll figure out, okay? So
All right.
I want everybody to come back. Thank you, Farouz.
You're welcome. Thanks.
All right. Could I solicit some answers to you guys? Answer to the first one. Is it true or false?
True.
Number two,
False.
False.
okay, so I'm gonna put your answer there, okay? So this is a true, false. 3,
You said it's true.
true. 4,
False.
5,
Someone says 5 is also false.
6, 'Remember the criteria we said? True, always true. False once, false. 7. 6 is false.
Yeah.
7 is,
7's true.
all right. Do you think you get them all correct?
Yeah, for the most part.
Okay. So I'm gonna grade your work. Have you guys changed your mind? Oops. This is a good. This is a good answer. 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 You guys are pretty good for the first 7 questions, but this is wrong. The first one actually is a number 1 mistake. Number 1 mistake. The calculus professor, the calculus author, the textbook with the calculus author put it on top 1, top question, top popular wrong answer. Okay. And we're gonna cover the rest of these throughout the chapter, throughout the semester, throughout the rest of the semester. Okay. And I wish to say congratulations to all of you guys to get 6 out of 7 correct. That's pretty good. That's pretty good. Okay. But the first one is absolutely critical. It's absolutely critical. Why this is a false statement. Okay. This is a false statement. This is a false statement. So we're going to start from there. We're going to start from there. Are you ready?
Yeah.
So I'm going to going back to my board. Okay. The first question, if x is any real number, then the square root of x squared equals to x. Why this is false? Can you get a counterexample? You should be able to come up with a counterexample, yeah? Because now you think again, right? Because if this is true, what does what does it say? If x equals to, that means if x is any real number, right? If x is any real number, then this is true. So when I give you x equals to -1, what will happen? X equals -1. Is that true?
No, it would be a positive one.
That's right. False ones, false. False ones, false. That's why this is a false. And this
Okay,
all
that makes
time,
sense.
I'm sorry?
No, I was just saying that makes sense. I don't know why I didn't think of that like right off the bat.
Right. Good. I'm glad that we have these interactions. So when we think about, when we read this statement, we have to understand what x can be. Okay, so when we're thinking through this, and you need to think, oh, x can be any real number. That means x can be positive, 0, negative. If I randomly choose a positive number to see if it's true, I plug in 0, see if that's true, and plug in a random negative number to see if that's true. So that's it. That's the way you check. If you do mental check, you can check it that way. Or you just get a piece of paper and you see, oh, let me check if that's true or not. Because once you have one counterexample, if it false once, it is false. Remember, we talk about mathematical truth is absolutely judged by these criteria. True has to be always true. Okay, so now what will be the right answer? What will be the right answer? Okay, so if we're going to use the remainder of the time to discuss this. Okay, we're going to use the remainder of time to discuss this. So this will take us back to I think we have some exercise about absolute value somewhere. Okay, so we're gonna have a little discussion here. Oh, by the way, before the end of the class, I wish to tell everybody tonight, because tomorrow we have some arrangement about tomorrow, right? You guys know that, right? I will have recordings available tomorrow, but tonight I'm going to do the recording. I'm going to do the recording at 6 o'clock, from 6 to 8. And all of you guys are welcome to attend. I will send you the link. It's going to be my it's going to be the same link to my office hour. Okay, but Farouz has some proposals for you guys. Our TA has some proposals for you guys. Farouz, you want to go ahead to announce to the class?
Yes, ma'am.
If you want to do it, I mean, you don't have to.
Yes, definitely. I will be here. And that, where do you want me be? Where do you want me be? I can basically I have to give my Zoom number, right? You
Right.
cannot use your site here. So my proposal is same time tomorrow, 8 to 9. What is it? 8 to 9:40. Our class time. I'm going to be giving my Zoom number so you can stop by and we can, work on any question you have so far, and especially today's question, Professor brought it up, homework question, concepts, truth table, the logics, everything, anything. So basically, yeah, I'm gonna be in my Zoom, and then you are more than welcome to join to that meeting. And it's gonna happen to the same class, your next class too. 11:15 to 12:50. If you miss this class, this window of time, then you can join the other one. Doesn't matter. It is online.
Okay. Thank you. Farouz, you're gonna send the Zoom link to them?
Yes, I tried send it through Pronto, right? And also sometimes I go old-fashioned way. Also, I type it here in the chat, and I'm gonna write it. I'm gonna check my new marker, Professor. My Zoom number is 4545578645.
Well, he has amazing memory. It looks like he remembered those numbers.
I guess the numbers were also repeating themselves.
Okay, there's some patterns.
45, 45, 57, 86, 45. So tomorrow for Thursday from 8 a.m. to 9:40.
No, tomorrow is to 10:05.
10:05. Okay.
But
sorry,
you
what-
can do 9:40.
No, that's fine. Whatever you want. Whatever you.
So tomorrow's class, if you guys are, because I will be assigning you guys some homework. You guys already have some homework. If you need help or anything from the notes, I would imagine Farouz could help you guys. And Farouz, oh, you're gonna give him both time to them?
Yes, if they miss it, they can be here. If they need more time, they can stop by first session and then stop by second session. Doesn't matter, you know.
Okay, so this is the other time. This is my other class. Okay, so tonight, so let's talk about tomorrow. Okay, tomorrow, you can meet Farouz at this time. Okay, and tonight, okay, I will be recording the lecture for posting for the post tomorrow. Okay, so my recording times, okay, my recording times is from 6 to 8:05. PM. Okay, and another session is 8:10 to whatever. So 9:50.
I see Nicole has a raised hand, Professor.
Okay, there's a raised hand. Yes, Nicole.
Yeah, the homework, is just for us to do. We don't send it anywhere? Or do we?
No,
send-
you don't send me homework. I will be quizzing you on homework.
Okay, thank you.
Thank you. Okay, so tonight is my recording time. I invite all of you guys. If you can come, great, because I would enjoy that interaction with the students. Or you're doing your tomorrow's class tonight. Okay, and these recordings will be made available as soon as they're available. And tomorrow I'll be out for a procedure, so I will not be teaching the class. So you'll be watching the recording. Is that clear, everybody? I will send you the link. The link is my office hour link. That goes to my personal room. Okay? Is that clear about the plan for tomorrow
So Professor,
and tonight? Sorry?
Question here. So these two sessions you have, one of them is good enough. For example, if I stop by at 6 to 8:05, that would be same thing as 8/10?
I'm not sure they're exactly the same because
Yes,
depending my progress in this class,
yes,
but Feroz, you don't have to come, really. You have dedicated so much time. I'm not sure you get paid for those hours.
Yeah,
And you can watch the recording.
okay,
And,
okay. Yes, yes, yes. I don't want to miss because, you know, my way of learning is learn from any experience our professors has. Imagine how much experience I will add, right, through my tutoring time. So either recording or live, same thing as you said. I can watch your recording if I can.
okay, guys. So how about we got the link, we send out the link now. Feroz, how about you send the link to them now?
Okay,
So
let
they have
me
it.
see. Yeah.
And you guys,
Let me see.
yeah, go ahead and send it. And I just want to make these announcements. All are welcome. I will send a separate message from inbox and pronto after class. Okay, about my recording time. Anyway, so we just talk about this is wrong, right? This is wrong. Now your question would be, what would be right? Right? Yes, this statement is false. Do we have a true statement for it? The answer is yes, yes, yes. Okay. And what is that a true statement? Okay. What is that true statement? I'm going to put that true statement on the top. Okay. That true statement on the top, I want you to write it down. You may or may not understand this completely. We will get to it. That is a true statement. For any real number. Thank you, Feroz.
You're welcome, ma'am.
Okay. And my link, you guys know it's on the it's just my office hour link. All right, so I'm going to continue the lecture even though we don't have much time left. We have a little bit time left. Okay, we have a little bit time left. Okay, now next I would like to cover basic one, the table of basic one. We're going to get started. We're going to get started. Okay. And tonight we're going to continue on this. We're going to continue on this. How do we demonstrate this is true? We'll get there. We'll get there. Okay. So now I want you guys to look at a basic one table. Basic one. In your notes, it's on page number 5. Page number 5. Page number 5. Okay. And we will continue on this basic one. Okay, we'll continue on this. So next, we're going to introduce the definition of function again. Do we know what the definition of function? The definition of function. A function is a rule that, hey, you guys, I need your help. Please get involved. That assign
To each element X in a set of A exactly one element called f of
Thank
x
you.
in a set of B.
Wonderful. We talked about this before, haven't we? Right? It's the input-output idea. That's the idea, right? And I said in the entire semester, the theme is function. The theme is function. So a function is a rule. Okay, a function is a rule. This is a key part of this is a key part of this definition. It's a rule. So we have a rule. We have talked about rules, right? So it's a rule. Okay, this rule takes an input. It produces an output, and the output is called f of x. Okay, and where is this x from? Right? It tells us it's in a set of A. Okay, it's in a set of A. In a set of A. And what is, where would f of x be in? It's going to be in a set of B. Right? So when we have a rule, the first thing we would be thinking of, what can this rule apply to? i.e., what can be the input? If we can gather all the possible input that this rule can apply, and that makes a domain. Have you heard about domain? So naturally, we'll be asking the question, right? So X will be from a domain of the rule X, okay? And then we apply the rule. We apply the rule and produce this f of x in the set of B. If this is the domain, and that will be in the range. So once we have a rule, naturally we'll be asking, what are all the possible numbers can this rule apply to? And if we gather all of those numbers that this rule can apply to, and that makes the domain, the consequence of applying the rule to all possible numbers make the range. Okay, so in shorthand notation, we have domain, okay, and the numbers we chose are from the domain. Okay, I'm going to introduce a little notation for you here and there. You will find them useful in time when you're in calculus class, okay? This little symbol is telling you X belongs to the domain, okay? Which is saying the same thing, X is from the domain. And this X is going through the rule, it produces an output, and the output will belong to the range. Shorthand notation R. Range. Do you follow me? Okay, so let's see, under this umbrella under this definition, how many functions could there be? Right? Now, let's look at the rules. What can be the rules? The entire table, basic 1, are all the basic functions. Okay, I coined the words basic functions. So let me see how many rules could there be. Okay, so I'm going to make a table. 1, 2. All of these are rules. There's a rule here. There's another rule here. Another rule here. How many rules? As many as you can wish. You can wish for. In the table of basic 1, I give you 22 rules. Okay, I give you 22 rules, and we're going to study each one of them. Based on these 22 rules, we can add them, subtract them, multiply them, divide them, composite them, and we'll produce many more rules. Are you guys with me? Are you guys with me? For example, there are 22 rules, okay? Rule number 1, right? That rule has its own domain. Okay, and it has its own range. And we're going to cover each one. You can see for each one of these rules, they have their own domain, they have their own range. What you learned in the past 5 courses, it's all about these functions, rules, and their domain and range in the 2 kinds of statements. Statement or if statement. And what you can do with these 22 basic functions, you can produce more functions, okay? By doing what? One function plus another function. One function subtract another function, right? One function multiply another function. And then one function divide by another function, right? And what is more, have you learned about F composite G? So from these basic functions, we can add, subtract, multiply, divide, compose. How many functions do you think we can produce? Infinite. Infinite. These functions we produce might include the function that works for you in your favorite computer game that allows your favorite character jumping up and down, left and right, and so on and so forth. Are you guys with me? I'm a bit confused. Okay, I see a message. I'm a bit confused. About what? About what I just talked about? Chase? Okay. I'm going to elaborate tonight. Okay, we're running out of time. Okay, so come to today's lecture, tonight's lecture, or listen to the recording tomorrow. I will be talking about each one of these rules. Okay, I'll be talking, I know I might have been carried away a little bit. Okay, we're going to be talking about each one of these rules, 22, under the same umbrella, under the same definition. I want you to see what does this definition encompass? Okay, so just be patient with me. I know that I might have spoken too much of those general concepts. You're not quite follow me. I understand that, but I will be going to details, and we're going to cover all 22 functions, and starting from tonight or tomorrow morning, if you choose to listen to the lecture tomorrow morning. Okay. Once again, you can attend both sessions tonight, or you can attend one session, but since you're in my class at 8 o'clock, I recommend if you attend, you attend the first one. But if you wish to attend the second one, no problem. That's great. Okay, but these 2 classes, even though they're the same course, I actually may go at a different pace, depending on the needs of the different classes. Okay, but without further ado, and if I don't see you tonight, I will see you Tuesday next week after Labor Day. And you should expect another quiz coming your way. And once again, I'll be out for a surgery and I should be back on Tuesday. Thank you very much. Thank you, Farouz.
Thank you, Professor. You asked me to step by for office hours.
Yes, if you have time, I'm thinking maybe, I think there's some other options you might be able to use to show your work to students.
Okay, so I step by and we discuss it.
Okay, if you wish, okay?
Thank you, thank you.
Thank you. Thank you very much, Frankie. And thank you, everyone.
All right, thank you. Have a good day.
Thank you. Have a good day.
Thank you.
Thank you.
Thank you, class. Have a good
Thank you,
day.
guys. Good job. Keep at it.